All right, picture this. You're at the grocery store, standing in line. The cashier grabs your bag of chips, drags it across that little glass window, and beep. Just like that, the price shows up. 2 seconds later, your total's done. But have you ever actually stopped to think about what's happening when that beep goes off? What's that black and white striped code even saying? How does a simple pattern of lines instantly tell a computer what you're buying? Let's break it down, because barcodes are way more fascinating than you think. This is LearnedToday. So, at its core, a barcode is just a way of writing numbers, but in a form that machines can read. Think of it as a visual language for computers. Humans use letters and words. Computers use lines and patterns. Each barcode is basically a binary code, a series of ones and zeros represented by alternating black and white bars. The black bars absorb light, the white bars reflect it. That's how the scanner can see it. When you scan a barcode, the red laser isn't reading the black ink itself, it's measuring how the light bounces back. The scanner shines a red light across the code, and a sensor detects the reflected light. White spaces reflect a lot of light. Black bars reflect almost none. The scanner then converts that pattern of light and dark into an electrical signal, which gets translated into digital ones and zeros. Those ones and zeros form a number, and that number is what the computer uses to look up the product in a database. So, when you scan that bag of chips, the scanner reads something like 02840012345 It doesn't know what chips are. It just sends that number to the store's computer system, which says, oh, that's sour cream and onion chips, $2.49. That's why the same bag of chips might scan differently at 2 different stores. Each store's database assigns its own price. The barcode just provides the ID. Now, you've probably seen that most everyday products use a specific kind of barcode, that rectangular one with a bunch of vertical black lines. That's called a UPC, or Universal Product Code. It was introduced in 1974, and fun fact, the very first product ever scanned was a pack of Wrigley's gum. The UPC is still used today all over North America. Let's take a closer look at how a UPC is built. It's made up of 12 digits. The first digit is a category or system number. It tells the computer what kind of product it is, like grocery, coupon, pharmaceutical, etc. The next 5 digits identify the manufacturer, basically, who made the item. The next 5 digits identify the specific product, what it actually is. And the last digit is a check digit, which is like a built-in spell check that verifies the code was scanned correctly. Here's how that check digit works, and this is actually pretty clever. When the computer reads the code, it runs a quick math formula on the first 11 digits. If the result doesn't match the 12th digit, it knows the scan was wrong. That's why if a barcode gets smudged or bent, the system can instantly catch errors and ask you to rescan it. Okay, so that's the basics of a UPC. But not all barcodes look the same, right? You've probably seen those square, blocky ones like what's on your concert tickets or restaurant menus. Those are QR codes, short for quick response codes. While UPC barcodes store information in one direction, left to right, QR codes store it in 2 directions, both horizontally and vertically. That's why they can hold way more data. A QR code can contain a website, link, contact info, payment details, even full paragraphs of text. QR codes also have built-in error correction. Even if part of it is scratched, torn, or covered, your phone camera can still read it. It does this by using math to fill in missing data, sort of like how your brain fills in words when you read a smudged sentence. That's why QR codes exploded in popularity. They're durable, fast, and easy for any phone camera to read. But back to our friend, the humble barcode. The technology behind it isn't new. It actually dates back to 1940s. The idea was first patented in 1952 by 2 graduate students, Norman Woodland and Bernard Silver. They were trying to solve a problem grocery stores had even back then long checkout lines and price tag chaos. Their original idea used patterns of concentric circles instead of lines, so that scanners could read them from any direction. But the tech wasn't ready yet. Lasers and digital computers didn't exist. It wasn't until 1970s, when laser scanners and microprocessors became common, that the barcode finally took off. And once it did, it completely revolutionized retail. Before barcodes, stores had to manually type prices for every item. There was no easy way to track inventory. Employees literally had to count products by hand. With barcodes, every scan automatically updates the store's database. It tracks how many units sold, adjusts inventory, even helps manage restocks. Today, it's not just grocery stores. Every industry uses barcodes. Hospitals use them to track medications and patients. Airlines use them for boarding passes and luggage. Warehouses use them to manage entire global supply chains. Here's something most people don't realize. That little beep sound when a barcode scans successfully, that's not just for you. It's an audible confirmation for the cashier. It means the scan registered correctly and the data went through. A lot of early barcode systems didn't have screens, so the sound was the only feedback. It became so iconic that even digital scanners today keep it as a sort of barcode language. Now, you might be wondering, what about all the different barcode designs out there? There are actually dozens of barcode formats. UPC is just one. There's EAN, used internationally, code 128 used for shipping and packaging, and data matrix, which you'll often find on electronics or medical devices because they can fit on tiny surfaces. Each format has its own way of encoding data, but the principle is always the same: light, reflection, binary code, database lookup. And here's a fun fact: those gaps between the bars, they're just as important as the bars themselves. Each bar and space combination forms a pattern that represents a digit. That's why even a tiny scratch can mess up a scan. It can throw off the spacing, which changes the binary code. It's like swapping a letter in a word. Suddenly, it means something else. So let's zoom out for a second. That simple beep we hear thousands of times a day in stores, airports, hospitals represents one of the most quietly revolutionary systems ever built. Barcodes are the reason modern commerce even works. They made global logistics, inventory management, and fast retail checkout possible. The beauty of barcodes isn't that they're flashy or high-tech, it's that they're simple, universal, and reliable. They take something as old as light and reflection and turn it into language for machines. Every time you hear that beep, that's your world running just a little smoother. So, next time you're at checkout and the scanner flashes red across your can of soda, take a second to appreciate what's happening. Beneath that tiny moment is a system that connects manufacturers, databases, retailers, and customers in milliseconds, all through a series of lines that your eyes can't decode, but your world depends on. That's the barcode, a quiet invention that taught computers how to see.